Hey kids, Flexing Teacher Weber here. I hope you're having a good day. We have started a unit on solving algebraic equations. Earlier in the year, we already finished a unit on algebraic patterns and creating math equations. Now we're going to focus on solving math equations. How we started out is we started out with some guess and check problems where kids had to guess an answer from a word problem, and then we applied some algebra to it and created an algebra equation that would also solve the word problem. So we did one like this, one like this. Then what we also did is we looked at just some single-step algebra equations that involved negative numbers, some negative integers. We looked at solving them and checking them. So the other day we did 4 or 8 examples together in class, and then we did an assignment called Find a Match. One of the things the kids have to do today is correct that assignment using the answer key. And then what we did today is we also did some more problems together. So I gave this problem, which is a little bit different than the ones we did before. It said find 3 consecutive odd whole numbers whose sum is 27. Well, after some guessing and checking, the kids discovered that you could do 9 plus 11 plus 13 is not the answer, but what they did discover is you could do 7 plus 9 is 16 plus 11 is 27. So those are 3 numbers. They're consecutive, which means one after the other, and they're odd whole numbers. Odd, so 7, 9, 11. And those numbers add up to 27. So some kids guessed and checked that in teams. And then what we did is we applied some algebra to them. So if we didn't want to use guess and check, we could assign some unknown values to these numbers. We could say our first unknown value would be x. Now our second unknown value, since it's a consecutive odd whole number, it wouldn't just be 1 above x, it would have to be 2 above x. So our first whole number is x. Our second whole number would have to be 2 above x. So we'd say x plus 2 is our second number. And then our third whole number would have to be 4 above the original one. So we could say x plus 4 equals the third number. And you can see that in the actual answers, right? 9 is 2 above 7, and 11 is 4 above 7. Then what this says is these numbers have to add to 27. So x plus 2 plus x plus 4 has to add to 27. And then what you do is you group up your x's. So I have a total of 3 x's. And you group up your whole numbers. I have 2 plus 4 is 6. And that equals 27. And there's a math equation very similar to what we studied earlier in the year, except earlier in the year, we wouldn't have had a value for that math equation. We would have had another unknown value. We would have said that equals y. But in these situations now we're being given a value. We're being given, in this case, those numbers add up to 27. And we want to know the value of x. So the way you get the value of x is you make it by itself, you isolate it. And you start doing that by simplifying it and doing it to both sides of the equal sign. So what I want to do first is make positive 6 turn into 0. And I do that by subtracting 6. And it's got to be done to both sides of the equal sign to maintain the balance. Well, the plus 6 minus 6 goes away, and I'm left with 3x equals 21. Now remember, this means 3 multiplied by some number equals 21. If I want to show the value of 1x and make multiply by 3 go away, I divide by 3. And that will show me the value of 1x. And I've got to do it to both sides of the equal sign. 1x equals 7, or x equals 7. It's the same thing. Now, if we said x is equal to 7, check this out. X is 7. X plus 2 has to be 2 above that, so 9. And x plus 4 has to be 4 above that, that's 11. And that's exactly what we got when we guessed and checked. So we can take many, many situations and apply algebra to them. Let's look at another one. So find 4 consecutive odd whole numbers whose sum is 80. Well, consecutive, one after the other, odd, and they have to be whole numbers. They add up to 80. So after some trying, the kids got 17. I want to do this in blue. 17 plus 19 plus 21 plus 23. Those numbers add up to 80. To apply algebra to them, you would do the same thing as before. We're going to have 4 unknown numbers. The first one will be x. So x will be the first unknown number. The second unknown number has to be 2 above x because they're odd whole numbers, so always skipping one. So the next whole number would be x plus 2 equals number 2. And the next one would be x plus 3 equals, not an x plus 3, x plus 4 equals number 3. And the next one would be x plus 6 equals number 4. Because we're always going 2 above the previous one because we're skipping a number every time. Now you take those unknown numbers, x plus 2 plus x plus 4 plus x plus 6, and you add them up to equal 80. You group up your x's. There's 4 of them this time. You group up your whole numbers. 2 plus 4 is 6, plus 6 is 12. And you get this math equation, 4x plus 12 equals 80. Having some trouble writing tonight here. You want to get the x by itself, so you do it by subtracting 12 from both sides of the equal sign. And you get 4x equals 68. To show the value of 1x, you divide by 4. And you do that to both sides to maintain balance. And you get 1x equals 17. Or x equals 17. Now, if we go back to our original unknown numbers, if we said x was 17, then x plus 2 would have to be 2 above that. X plus 4 would have to be 4 above x. And x plus 6 would have to be 6 above x. And those are the original numbers we guessed. Now, what we were actually solving here was a 2-step equation, which we'll do next week. But I wanted to do this just to show where equations can come from, right? They're out there in everything that we do. We can apply equations to so many things. But what we're focused on right now is focusing on just solving single-step equations with negative integers. So let's do a little review of these. We already did these the other day, and we already did an assignment on them, but I thought we'd sort of start small today in remote learning and just do a review of this. So the idea with these questions is you want to show the value of the variable, the x, and you want to show that by doing something to both sides of the equal sign to show the x by itself. So in this case, to get the x by itself, I want to make the positive 8 go away, and I'll do that by subtracting 8. And if I do it to that side of the equal sign, I have to do it to the other side. And positive 8 minus 8 goes away, and I'm left with x equals negative 12 and negative 8. The signs are the same, so I add them, and I get negative 20. Now with all of these, I like the kids to check them as well. So here's the check. You write down the original equation. You replace the x with your answer. And you check to see if this statement is true. Well, negative 20 plus 8 does equal negative 12. Both sides of the equation are equal. We have that equality that we want. So it's correct. When we do these on a hand-in assignment or a test, you'll get 1 mark for showing what you do to both sides of the equal sign, 1 mark for the answer, 1 mark for the check. Okay, and they're just all different variations of these. In number 2, the variable's on the opposite side of the equal sign. You want to show the value of the variable by making it by itself. So you want -6 to go away. You do that by adding 6, and you have to do it to both sides of the equal sign. -15, +6. The signs are different, so I subtract, and I have more negatives, so the answer is negative. On the other side of the equal sign, -6, +6 turns into 0, and I'm left with a positive y. Now these variables, these letters, are just like integers. If I have a positive sign in front of it, I don't need that positive sign in there, so I can just say -9 equals y. For the check, write down the original equation, substitute in your value for y, in this case it was -9, and ask yourself, is that statement true? Does -6 plus -9 equal -15? It does. Both sides of the equation work out, so we're good. Let's do a couple more here. Now in number 3, you want to show the value of n, so n take away -5 equals -18. Well, what you want to recognize here is that this equation can actually be simplified before we solve it. Subtracting a negative is the same as adding a positive, so rewrite it like this. Now you want to get the n by itself, so you want +5 to turn into 0. Do -5, and do it to both sides of the equal sign. Now +5 minus 5 turns into 0, which is what you want, and n equals -18 and -5, the signs are the same, so I add them and use the negative sign. Next, I check it. I'm going to write down the equation that I actually simplified. I'm not going to write down the minus negative. I'm just going to write down the n plus 5 equals -18. I'm going to substitute in -23 for n. And I'm going to ask myself, is that true? Do both sides of the equal sign balance out? Well, -23 plus 5 does equal -18. So both sides of the equation are correct. Boom. Last question here, 7 minus x equals 13. Well, I want to get the variable x by itself. So to make this +7 go away, I will subtract 7. And to maintain the balance, I'll do it to both sides of the equal sign. Now 7 take away 7 goes away, which is what I want, but check this out. I don't just have an x left over, I have a negative x over. And when we're dealing with integers, we can't just drop negative signs. The other side of the equal sign, 13 minus 7, is 6. We're not done yet, because we don't want to know the value of negative x, we want to know the value of positive x. So, to do that, I use the idea of equality. I do the opposite of negative x, which is positive x, and then on the other side of the equal sign, I do the opposite of +6, which is -6. So the value of x is -6. Now let's check it. Both sides of the equation should balance if this is true. So I write down the original equation. I substitute in -6 for x. I remember that subtracting a negative is the same as adding a positive, so this is like 7 plus 6. And yeah, that's true. That statement is true. 13 equals 13. The equation balances out, so it is correct. So I'm going to give you another assignment today where you have to solve and check single-step math equations, showing all your work just like this. I hope that makes sense. That's all for now. Flexing Teacher Weber, out.